performance parameters such as errors, delays, and etc. in the product. This is the actual use of Netsim emulator. These are our existing customers right now. So let me directly take you to the product. I hope my screen is visible. If you have any queries, you can ask. I think somebody unmuted, so if there is any query, you can ask. Okay. Okay, this is the home screen of. Please mute yourself if you are not having any queries. Mute.
Students, please mute yourself.
Okay, I have muted them. Okay, fine. Let me continue. So this is the home screen of Netsim, where you can see all the networks or all the components that are installed. This is the whole package. I have all the licenses, so I can see all the components over here. So for today's demonstration, I'll just make use of. First, I'll create a simple scenario and I'll show how simple it is to run a scenario. Then let me move on to the next part. That is based on your interest. I will be explaining some of the other advanced networks also. So let me choose internetworks as a simple simulation example. So this is the home screen of, this is the design window of Netsim, where you can see on top there are devices such as nodes, switches, routers, and access point. This is an internetwork, so you'll be able to see these kind of devices and applications to create the flow of traffic between the end nodes. Then we have some of the advanced properties or advanced traces, is plots, packet trace, and event trace. Then we are running the simulation. Then we have some of the display options. So first and foremost, there are only three or four steps in entire this simulation. The first step is choosing a network. So I have already chosen it. That is internetworks. Second step is to design a scenario. And third step is to configure the devices that have dropped in the scenario. And the fourth step is to model the applications between the end devices or end nodes. And finally, simulating the scenario. So the first step, I'll start with creating a simple scenario. Let me have two wired nodes and say one wireless node. So in order to connect these devices, I require either switch or a router and an access point. I'll take help of access point to connect the wireless node. I'll take help of routers to connect the wireless network and the wired network. In order to connect these two wired nodes, I'll take help of L2 switch. So now I have scenario. Let me connect those devices. So whatever I did was just a click and drop, and connection is also clicks. Not any, there were no any tracks or something such kind of things. Just clicks. The scenario is done. So with a few simple clicks, I have created a simple scenario. There is one LAN and one WAN with one WLAN, wireless local area network. So the next step is configuring the devices. In Netsim, both devices as well as links can be configured. So let me go to one of the device, this wired node. So I was telling that Netsim is a full stack simulator. That is, all the layers TCP/IP model is implemented in Netsim. So you can see all the layers: application layer, transport layer, network layer, and under interface you can see data link layer and the physical layer. So all the layers are implemented in Netsim. So let me go through the general properties first. Under general properties, you can change device name, x and y axis of the device. So if you are creating a scenario in map view, then it will be a latitude and longitude. Z axis is reserved for the upcoming releases or the future releases, where we are going to have a 3D view of the scenario. So it is reserved for the upcoming releases. Wireshark, as I was telling, we are interfacing with Wireshark. Wireshark is open source, so we are giving with the product. So we have directly interfaced with Wireshark. So either you can keep it disabled online or offline. Online, if you keep online, then the simulation and the Wireshark packet capture will be simultaneous. That is, you can see both the windows at a time. Offline, the capture will be done in the background and it will be saved in your saved scenario, like the saved location. Wherever you are saving this experiment, you can then manually open it via result dashboard. So let me keep this disabled, and then we go to application layer. Application layer implementation of SDN. We can make this scenario, the current scenario, as an SDN based scenario, that is having one controller and making all the other devices controlled by this controller. By default, there will be no SDN implementation. We can make the settings to make it SDN based scenario. Then coming to transport layer, we have implemented two protocols, that is TCP and UDP. Either the simulation, like either the scenario will run under TCP or UDP. This selection of protocol, that is TCP or UDP, is done by the application layer that you can see while you are modeling the application. And let me go to that. Let me explain you in the next step. So main two protocol implementation is TCP and UDP in the transport layer, and in the network layer, yeah, you can see ICMP, IGMP, and you can also have static routing based on the IP address of the device. So all these can be configured in the network layer, and in the interface layer, you have you can modify the existing IP address, and in the data link layer, it's only the MAC address, and in the physical layer, it is related to the wired node. So here it is a generic wired link, so there will be no major uh, properties related to that. So next is the wireless node. Wireless node, all the layers remains the same except the physical layer. Physical layer, we have implemented 802.11 protocol, and it is as per IEEE standards. And understand that we have A, G, P, N, AC, and P. So these are the other protocol parameters related to IEEE 802.11, which can be further modified. So this feature is also available in the academic version as well as the standard version. Only thing is protocol source code modification is not allowed in academic version. So this is the properties related to the wireless link, wireless node. Now I will be showing you the properties related to the wireless link and the wired links. The wireless links can be further modified. It is based on the channel characteristics. The propagation model, currently it is only air. In the upcoming releases, we are going to have acoustic networks. So we'll be having both air and acoustic as the options. But currently we have only air, medium, and then channel characteristics, no path loss and shadowing, path loss fading and shadowing. And some of the path loss models, log distance, cost 231 Hata urban, cost 231 Hata suburban, and indoor office, indoor factory, and etc. And also we have newly implemented two-ray model. In addition to that, we also have path loss metrics file. That is, if we have field data, then you can give that field data as an input to Netsim, or else any data that is generated in the third party software such as MATLAB, then you can give that file as an input to Netsim condition, with one condition that Netsim has its own format of reading the metrics file, so path loss metrics file. So you have to make sure that the format is in the readable format of Netsim. So these are the parameters that is related to wireless link properties. Under wired link, you'll be having minimum property change, that is only these speed and BER. One is bit error rate, and the speed of the link can only be modified. So with this, I have completed two steps. That is creating a scenario and modeling the like configuring the devices. So two steps are done. So the third step is to model the applications. Now I'll be modeling the application. Modeling the application is nothing but uh, initiating the flow of traffic between source and the destination. So let me click on application. So under application methods, firstly you can also have multiple application in the same scenario. You can use addition or subtraction, like use this option to create a number of applications based on your scenario. So for this example, I'll be creating one application. That is application methods. We have unicast, multicast, and broadcast methods. Under application type, we have CBR, custom peer-to-peer, email, HTTP, newly implemented COAP protocol, then FTP, video, voice, and etc. So we'll be creating a simple CBR, that is constant bit rate. So here I'll be selecting source ID and the destination ID. So as you've seen, every scenario or each device in a scenario has its own IDs that is unique in the scenario. So when I consider wired node has one, two, three, four, so five, six. So these IDs are unique, whereas the name of the uh, name of the device can be changed, whereas ID remains the same. So based on that, we are going to create applications. So now I'll be creating application source IDs, selecting as one and destination as three. Yeah, and there are a few more parameters: start time and end time of the application, when to start, when to end. Also, if you want to have encryption implemented, then we have encryption models such as AES, DES, XOR, TEA. When you purchase standard version of Netsim, if you want to have your own encryption algorithm, we also have one example related to that. We have implemented, like user has implemented their own encryption algorithm, the file exchange, that is modifying the existing source code and implementing the encryption model. So this is one of the example that I'm telling for protocol changes, like protocol modification. Here, as I was telling, the transport layer protocol, the protocol selection is done over here, whether the application should run on TCP or UDP. So that decision is taken in the application layer. So let me run it over TCP itself. Then packet size and interarray time. These two parameters are used for the purpose of generation rate. Like if you want to generate in 100 Mbps, 200 Mbps, Gbps, so all that calculation is done with the help of packet size and interarray time. with the help of the formula. So this is related to application. Click on OK. So now you can see here I've created an application from Wired Node 1 to this wireless node 3. So with a few steps, we have created a scenario, configured the devices, and now we have created an application. It is application is nothing but the flow of traffic from the end nodes to the other end node. So now let me enable some of the uh, advanced plots and packet trace and event. The final step is to run the simulation. So here simulation time is a virtual time. Our simulator is a discrete event simulator. So the simulation time depends upon the number of events that need to be occurred. So this is not same as the wall clock time. So let me run it for 100 seconds of simulation and packet animation. There are controls related to the packet animation. Either you can play and record, and don't play and record. Let me record this animation and then show you after the simulation. Play and record will show you simultaneously. That is, the simulation as well as the animation will run simultaneously. But let me avoid that due to the time. It will take more time for simulation. So let me do it faster. Let me run it for 100 seconds. So at the end of the simulation is completed now. At the end of the simulation, you'll be able to see the plots, the animation window, and the result dashboard. So let me take you to the result dashboard first. So under result dashboard, user can see the various result metrics tables, that is application metrics, TCP metrics, link metrics, queue metrics, all the metrics tables. Also, we have some of the other metrics, that is IEEE 802.11 metrics, and switch MAC address table that we had a switch. So switch MAC address table, and queue metrics, IP metrics, and so on. So if a user wants to have his own metrics table when he is doing his research, that is strictly related to this. Whatever I'm speaking is related to Netsim standard version. So if you want to have user metrics, custom metrics to be implemented, then it requires code modifications. Also, it is not great code mod. It's the greater part. It is small code modification is required in order to have custom metrics. Also, similar to metrics, also user can have custom plots. By default, Netsim generates link throughput plot and application throughput plot. So we have only one application. So one application throughput plot is generated here. You can see the application throughput plot. And similar to application throughput plot, we have